say we will be drawing the graph of, say we are taking the function f from R to R, fx equal to x square. We know very well that it will not be a bijective function, so therefore that we have to take R plus to R plus. So we will be only dealing with the positive part of x-axis and positive part of y-axis. Okay. So what should be the inverse function? If we take fx as y, okay, let me clear the screen first. So again we are writing that we are taking the function f from R to R, fx equal to x square. Now if we take fx to be y, then it is x square. So clearly what is x? It is nothing but root over of y. That means we can say that f inverse is nothing but root over of x. Okay, so we can see for the function x square on the set R plus to R plus, the inverse function is root x. So let us see whether it is becoming the reflection of the curve of x square on the line y equal to x. Okay, so here to draw the curve we draw it like this. We will write the equations here. So we are plotting x square. See, it is the curve for x square. I'm zooming it. Let us take the interval 0 1, and we are also taking the curve y equal to x. Okay, sorry, y equal to x square and y equal to x. So these are the curves where these are intersecting at the point 0 and at the point 1. See, the points are these 0, 0 and 1, 1. Now if we take any point on the x-axis, say we are taking the point A. So what should be the y coordinate? If the function is x square, then the y coordinate should be a square. Now here that we can slide the point A throughout the x-axis. We have to give the values. Say we are giving it from 0 to 1 and the step length to be 0.01. Now if we play this, a point will move along the curve. So along the curve a point is moving. So now what we need to plot? We need to plot some. So here we can say for any position, say here this is the point, this is the point, it is any point a comma a square. Now if we want to plot its inverse function, then what we have to take? This a square is nothing but f of a for the input a. So we can say this value here is a and this height is f of a. Okay, so f of a will be the x coordinate of in case of f inverse. So we have to plot the point fa comma a. That means a square comma a. Okay, so let us plot the point. A square comma E. Okay, so even if now we are playing the slider, then see 2 points are moving. Since we have set the values of the other point as the reflection of the point, reflection of this point, then whatever is moving here will be the inverse function. See, it is the reflection of the curve. It will look like this. Okay, so from here we can say that this is the graph of the function f inverse. So whenever we are getting the some function, we can reflect it on the line y equal to x. This is the line y equal to x, and we will get the inverse function. So let us plot the inverse function now. So as we know, the inverse function will be root x. See, the function, the graph is here. Can I change the color? Okay, no. See, the graph is here. So the first function, say this one, is the function y equal to x square, and the function here is y equal to root x. In the middle, it is y equal to x line. So this graph of y equal to x square is reflected on the line y equal to x, and we are getting the graph of y equal to x square, y equal to root x. So that's how we can say that x square has the inverse function root x. Similarly, if we try to draw the graph of x cube, it will look like this. And if we want to draw the inverse, so what should be the inverse of x cube? So say we are taking the graph to be f x equal to x square, x cube, it is y. Then what is x? It is the cube root of y. That means f inverse x, I am giving a step jump, it will be nothing but cube root of x. So let us plot the point. It will be x to the power 1/3. See, again it is the reflection of the point. If we want to check it, it will be the reflection of the point, reflection of the graph of f on the line y equal to x. Again, this function is y equal to x cube, and this function is y equal to cube root of x.